Okay, here I am, ready for action. This one's going to be one of the more harder ways to do probability, or for methods to solve probability questions. This is probability in combinations. I'm going to give you guys 3 examples. In general, there are 2 ways to solve this, and I'm going to be showing you both of the ways for the first one and then just one way for the next 2. 5 boys and 7 girls are randomly assigned to 3 groups of 4 students each. What is the probability that one of the rooms will be all girls? So we've got a guy, 5 guys, and then here's 7 girls. These are just random colors. I'm not trying to make a statement or anything. 1, 2, 3, 4, 5, 6, 7. And now we have 3 groups where 4 students are going to go into all of them. What is the probability that one of the rooms will be all girls? So we need to find the probability that 3 of them will go into here. And then, 4 students each, whoops. I'll put this one over here. And then we have all the rest. Just do whatever they want. We're going to find the probability of some case like that. Like that's an example case. So we need to first find the denominator, the total ways to assign them to it. So that would be the total outcomes that you could have. That will be 12 choose 3. Or, what am I saying? It would have to be 12 choose 4 because there are 4 people in the group. So we have 12 and we're just choosing 4. And then in the numerator, we're going to have these 7 going in there. And that would be 7 of them that I'm choosing to go in there. And then we also need to take into account the order. So if this one's being folded, we need to multiply our answer by 3 because it's not only this one that can be folded, but also this one or this one. So this right here would be our answer. Now let's show the other way for this one, which is using it as a dependent event. So we would say that there's 7 options over the total 12 to go into that box, and then we chose a girl, so now there's 6 out of 11 girls that can go in. There's 6 total girls that could go in over the 11 total people because there's also 5 guys. And then we're choosing 4, so we keep on going down over there, and then we're going to multiply by 3 because of the order. That's another way to solve it. You're going to get the same answer either way. Now on to the second problem. The 26 letters of the alphabet are placed on tiles and randomly it is separated into 2 equal piles. So we have basically the alphabet. I just noticed alphabet, it's like alpha and beta. That's definitely how it came up, and it's very interesting. I never noticed that. So we separate them into 2 equal piles. What's the probability that the word math is in there? So we're going to have math, and we have 9 other letters. And then here we have 13 random letters. So we need to find out first the denominator. What's the total ways that this could happen? The total ways that this could happen would be, so we have 26, the total ways that we could choose one of the piles would be 26 choose 13. And then the total ways that we could choose the combination with math in it, well, there's one way to choose the 4 letters math, just you have to pick all those letters, M-A-T-H. And then we also have, from the 22 remaining letters in the alphabet, we need to choose 9 of them. And then we also need to multiply by 2 because it could also be in that pile. And that right there is going to be your answer. Now, last question. There are 3 vegetarians in a class of 30 students. If 3 students are chosen at random, what's the probability that exactly one of the 3 is a vegetarian? So we have 20 students, and we are choosing 3 of them. So the denominator, the total ways you could do it, would just be 20 choose 3. And then the numerator, I see that there are 3 ways to choose the vegetarian, because there's 3 vegetarians and we're choosing 1. You could say 3 choose 1, which is 3. And then times, we have 17 non-vegetarians that we're going to choose 2 among 4. And that right there looks like it's going to be our answer. So these questions are typically pretty difficult basic probability questions, and I hope that I helped you further your understanding of them. Thank you much for watching, and goodbye.